So let's see how the struggle is going. Remember, we're multiplying exponents here, or multiplying, dividing, and we're going to a power. We're doing exponents with the same base. So you can see the base on all these exponents is 10. If we don't have the same base, none of what we're about to do applies. So it only applies if we have the same base. So when we're multiplying exponents with the same base, what do we do with the powers? The negative 8 and the 14 will be added. Very good. So this is negative 8 plus 14. So we got negative 8 plus 14, which is 6. So 10 to the 6th. When we are dividing exponents with the same base, what do we do with the powers? Subtract. So this is 9 minus a negative 6, which becomes 9 plus a positive 6, or 10 to the 15th. When we are taking an exponent to another power, what do we do with the powers? Multiply. What is 7 times negative 3? Negative 21. So those are the basics. Those make sense, Mark? Okay. Number 4 is just me being kind of mean. Yep. So we've got the fraction bar here. Says we got to do the top first. What do we get on top of that? Yeah, you're multiplying, so you're adding. Yep, adding the powers. 5 plus negative 11. Positive 5, negative 11 is negative 6. That's 10 to the negative 6. Then we do what's on bottom. 10 to the negative 9 times 10 to the third. What do we do with the powers again? Add them. Negative 9 plus 3. So you got negative 9, positive 3. Negative 6. So next we do the fraction bar. 10 to the negative 6 divided by 10 to the negative 6. When we divide, we do what with the powers? Subtract. What is negative 6 minus a negative 6? That becomes negative 6 plus 6, which is 0. That's 10 to the 0. We still got to go to the 5th power, which is, so still 10 to the 0. 10 to the 0, which is 1. Nope, it's the 0. You multiply the power, so it's the 0 times 5, which is still 0. So yeah, 10 to the 0 or just 1. So let's go down to number 5. Order of operations says we got to do this piece first. 10 to the 9th divided by 10 to the 7th. What do we do with the powers? Subtract. So there's 9 minus a negative 7. 9 minus negative 7 is 9 plus 7, which is 16. 10 to the negative 3rd divided by 10 to the 5th. Negative 3 minus 5, which is negative 3 plus a negative 5. Negative 8. Very good. Now we have to combine 10 to the 16th times 10 to the negative 8. Positive 8. Yeah, that's going to be 16 plus a negative 8. 16, negative 8 makes positive 8. Still to the power of negative 4. 10 to the 8th to the power of negative 4. Negative 32. 8 times negative 4 is negative 32. Good stuff? Probably didn't. But we need it for what we're about to do next. Remember, we talked about scientific notation yesterday as well, and how those place values are the powers of 10. Now this is 10 to the 0, 10 to the 1, 10 squared, 10 to the 3rd, 10 to the 4th, 10 to the 5th, 10 to the 6th, 10 to the 7th, and so on. This is 10 to the negative 1, 10 to the negative 2, 10 to the negative 3, 10 to the negative 4. And if we have a number like 720,000, put it in scientific notation, we write it as 1 digit in front of the decimal point. So we put the decimal point after the first non-zero digit, 7.2. Then we name the place value of that digit that's in front of the decimal point. That is in the 10 to the 5th place. So that's 7.2 times 10 to the 5th. Is that in scientific notation? That's how we do the scientific notation. Now we talked about the shortcut is you can just say, hey, the decimal point starts here, ends up here, it moved 1, 2, 3, 4, 5 spots. That's where you get the 10 to the 5th. If it was over here, of course, we know that's a negative power of 10 place values. So today we want to look at doing some operations with this stuff. Remember, when we add numbers or subtract numbers, number one, we must have the same name. When we were doing whole numbers, this came down to lining up the digits because each individual digit had a count and a name. The name of the digit was its place value. So if I have something like 7.2 times 10 to the fifth, what part of that implies a place value? Actually, it doesn't even imply, it just flat out states a place value. The 10 to the fifth is the place value. That is the name. So the 7.2 is the count. So when we're dealing with numbers in scientific notation, to add or subtract, they must have the same power of 10. And then finally, the second thing about adding and subtracting is we combine counts. Adding or subtracting, whichever operation we're using. And we keep the same name. So we must have the same name, and we're going to keep that same name. So let's take a look at 7.2 times 10 to the fifth. Now I'm putting it in parentheses, not because I'm saying we have to do something there first, but it's kind of like when I use parentheses with our negative numbers, I'm just separating it out so that that's a single number all on its own. So 7.2 times 10 to the fifth times 2.1 times 10 to the fifth. Do these have the same name? Yeah, they're both 10 to the fifth. So that means we can combine the counts. We're adding, so we're going to combine the counts with addition. 7.2 plus 2.1 is 9.3 times 10 to the fifth. We keep the same name when we add or subtract. So 10 to the fifth plus 10 to the fifth is going to stay 10 to the fifth. These have the same name. Yes, they're both 10 to the 9th. So we're going to combine the counts. 6.8 plus 7.9 is 14.7 times 10 to the 9th. We keep the same name. However, there's an issue with that answer. Can anybody tell me what it is? It's not proper scientific notation. Why not? There's more than one digit in front of the decimal point. We're only supposed to have one digit in front of the decimal point. We got to move that decimal point over to make that 1.47. Now, when we move the decimal point, we have to adjust our power. To figure out how to adjust the power, of course, the decimal only moved one place, so the power is either going to go up or down by 1. It goes up or down 1 by every place. What's that? Well, the easiest way to remember is the number got smaller. It went from 14 to 1. Number got smaller, power gets larger. So 9 plus 1 is 10. So 4.3 times 10 to the negative 12 plus 8.8 times 10 to the negative 12. Try that one in your notes quick. So 4.3 plus 8.8 is 15.1 times 10 to the negative 12th. What do we have to do with the decimal point? Got to make this 1.31 times 10 to the negative 11. Good. The number got smaller, so the power gets bigger. Negative 12 plus 1 is negative 11. A lot of people mess up that power with the negatives because they go the wrong way with it. What if we don't start out with the same power of 10? What if I have 7.8 times 10 to the 11th plus 9.63 times 10 to the 12th? Don't have the same name. Notice they're only different by 1. Because if they were more, it would make it really awkward. We can, just like with fractions where we change their name to make them the same, we can do the same thing here. Typically, we want to go to the larger name. Which is the larger name here? 10 to the 12th. So we're going to keep this one the same. 9.63 times 10 to the 12th. So this one has to become 10 to the 12th. Did the power get bigger or smaller? Bigger. Power got bigger, so the number has to get smaller. Ours is the opposite. So that becomes, move the decimal point over 1 place to make it smaller. So that's 0.78 times 10 to the 12th. So now we add 0.78 plus 9.63, which gives us 10.41. Yes? No? Yes? Times 10 to the 12th. But, what do we need to do? Move the decimal over 1.041 times 10 to the 13th. Very good. The number got smaller. Power has to get larger by 1. 12 plus 1 is 13. Any questions? You look confused, Mark. Okay. When we subtract, same type of rules apply. Must have the same name. Do these have the same name? Say yes. Yes, they're both 10 to the 13th. So we're going to subtract the counts. 7.6 minus 4.7 is 2.9 times 10 to the 13th. That wasn't so bad. Of course, you know me by now. It doesn't stay so easy. These have the same name. Yep, they do. So we're going to subtract. 6.42 minus 5.88 is 0.54. Times 10 to the negative 9. What's wrong with that? Yeah, there isn't a digit in front of the decimal point. There's only a 0. We can't have a 0. So we got to move it over to make this 5.4. This time the number got larger by 1 place value. So the power of 10 has to get smaller. What's negative 9 minus 1? Negative 10. So 5.4 times 10 to the negative 10. I want you to try this one in your notes. See if you can make this one work out. So, they have different names. So the 1.38 times 10 to the 17th we're going to leave because that's the larger name. This is going to become times 10 to the 17th. What's the 9.4 become? Becomes 0.94. The power got bigger, the number had to get smaller by one place value. This is one of the few times, though, where we would have been less work to go to the smaller name, but we're gonna have to convert it back. But we usually go to the larger name. Usually works better. So 1.38 minus 0.94 is 0.44, right? Times 10 to the 17th, and of course we have to adjust that by moving that decimal point. 4.4 times 10 to the 16th. Number got bigger, power gets smaller. Any questions? Adding, subtracting looks pretty good. Looks great. Now remember, when we multiply or divide numbers, one, we don't need the same name. Just like with fractions, we do not have to have the common denominator. Just like with whole numbers, we could do feet times pounds. It's just fine. Don't have to have the same name. We combine counts. Now, since we're multiplying or dividing, we combine them with multiplication or division. And we also combine names. That's how we can get away with not having the same name, is because we're going to combine the names. So if I have 4.2 times 10 to the 8th times 2.1 times 10 to the 13th, do they have the same name? No. Does it matter? No. We're multiplying, so we do not need the same name. 4.2 times 2.1 is 8.81? 8.82? What's a couple hundredths among friends, right? Times 10 to the, we also combine the names. 10 to the 8th times 10 to the 13th. When we're multiplying exponents with like bases, what do we do with the powers? Add them. So 8 plus 13 is 21. So we're going to have 3.5 times 10 to the negative 12th times 2.8 times 10 to the 7th. 3.5 times 2.8 is what's that? 9.8 times 10 to the negative 12 plus 7 is negative 5. So 4.7 times 10 to the 18th times 6.3 times 10 to the negative 9. Where do I start? Perfect. 4.7 times 6.3, which gives us 29.61 times 10 to the 10 to the 18th times 10 to the negative 9 is going to be 18 plus a negative 9, which is 9. But what do we need to do? Well, we have 2 digits in front of the decimal point. We've got to move it over. This is 2.961. Number got smaller, went from 29 down to 2, so the power gets bigger. So 9 plus 1 is 10. So 7.1 times 10 to the 8th times 3.6 times 10 to the negative 15th. Try that one in your notes. See what you come up with. So I multiply 7.1 times 3.6 is 25.56 times 10 to the negative 7. 8 plus negative 15 is negative 7. Then what? Move the decimal point over. 2.556 times 10 to the negative 6. Number got smaller, so power gets bigger. Negative 7 plus 1 is negative 6. So we can divide the same way. So let's say we have 2.556 times 10 to the 18th divided by 3.6 times 10 to the 11th. We're going to divide 2.556 times divided by 3.6 is 0.71. What do we do when we divide exponents with like bases? What happens to the powers? We subtract. 18 minus 11 is 7, so it's 10 to the 7th. Now, of course, this is not going to stay like this. Has to become 7.1. Number got larger, power gets smaller, so it's 10 to the 6th. So divided those. The numbers, just like the numbers get multiplied here, numbers get divided here. Let's do 4.41 times 10 to the 7th divided by 8.4 times 10 to the 13th. What do I get? Where do I start? Tell me what's the first step. 4.41 divided by 8.4, which is 0.525. times 10 to the -6. Very good. When we do 10 to the 7th divided by 10 to the 13th, we subtract 7 minus 13. Now what do we have to do here? Move the decimal, 5.25 times 10 to the this number got larger, so the power gets smaller. -6 minus 1 is -7. What do you think? Not horrible? How about a power? Just like we would with a variable, we take the number to that power. What's 1.2 to the third power? 1.728. Right? Times, how about 10 to the -7th to the third power? What do we do with those powers? Multiply them. So -7 times 3? -21. Good. So let's say we have 6.4 times 10 to the 8th to the 4th power. What is 6.4 to the 4th power?
1,677.7216.
Times 10 to the 32nd. Now here, we really got to move the decimal point, right? This number is way more than 1 digit in front of the decimal place. So we've got to move the decimal point here 1, 2, 3 places. To make this 1 point, I'm going to make it 1.6778. We're going to round it off there. Actually, it should go 1.678, not 778. 1.678. Times, now I moved the decimal point 3 spots, so that means my power has to change by 3. Did the number get bigger or smaller? Smaller. It went from 1600 down to 1.6. So the power gets larger by the 3. So 32 plus 3 is 35. Good stuff? Well, the power, you can do the 6.4 times 10 to the power of 4. We'll bump it up. The scientific notation on the calculator can be tricky because your calculator converts it to standard and back. On the graphing calculator, it's relatively easy to do. On the standard calculator, it can be funky. It can be weird. Let's do 1.728 times 10 to the 12th. We're going to do the third root. Now remember, we've said before, powers come in pairs. The root is the opposite of a power. We didn't really talk about roots yesterday. But first of all, what's the third root of 1.728? Got to do 3 math, x root, 1.728. There is a third root on there, but you already put in the 3, so go with x root, 1.728. Root. Then so 1.2 you get? 1.2. Good. How do we deal with that 10 to the 12th? Exactly. We divide the powers. 12 divided by 3 is 4, 10 to the 4th. If we're doing a power of a power, we multiply the powers. If we're doing a root of a power, we divide the power by the index of the root. So let's say it's just a square root. So let's say we have a square root of 5.76 times 10 to the -18th. Well, we have to do the square root of 5.76, which is going to be 2.4. 2.4. What do we do to the power of 10?
Same thing.
Yeah, it's a square root, which implies there's a 2 here. So negative 18 divided by 2 is negative 9. Happy stuff? On the same page as you were working yesterday, page 130, exercise 2.6, 59 through 81 is going to be a start on these. Then on page 133, exercise 2.7, 1 through 23, the odd, is going to be more of the operations of scientific notation. I'll let you guys have the last 9 or 10 minutes here to get started on those and ask any questions you might have.